We are team number C, and we're gonna be solving problems of ellipses. I'm Monse. I'm Marielle. I'm Balbina.
An official NFL football must measure 11 inches from tip to tip and have a height of 22 inches.
Definition of an ellipse. Sets of points on a plane where the sum of the distance from the two fixed points, foci, is a constant. Determine if it's a vertical or horizontal ellipse. In order to know if you have a vertical or a horizontal equation, you need to see whether the denominator on the first part of the sum is the biggest of the two. If it is, it means that it's a squared, which means that the equation of a horizontal ellipse. If it isn't, it means that it's b squared, which makes the ellipse vertical.
General equation for conic sections. Ax to the second power plus b y to the second power plus cx plus dy plus e equals 0. So for an ellipse to be an ellipse, it has to be b to the second power minus 4ac, and the condition is for it to be less than 0. So this is actually the condition for an ellipse to be an ellipse.
If your ellipse is smaller than 0, then you will have an empty set. And if your ellipse is equal to 0, you will have a point.
On problem E, I worked with the corresponding given center point of 5, 4. Then I found out the standard or reduced equation. X minus h over 2 divided by a squared minus y minus x squared divided by b squared equals 1. Then I found out the focus with the equation c squared is equal to a squared minus b squared, and then I plug in the numbers. Then I also had to find the a, the distance from center to vertices at major axis, the b, the distance from center to co-vertices at minor axis, 2a, the total length of major axis, and 2b, the total length of minor axis, as well as c, the distance from center to foci at major axis. In problem F, I work with a conversion of standard reduced form to general equation. First, I found out the least common multiple, multiplying a squared and b squared in order to find the product. Then, I cancel out and started to simplify it. As a result, it gave me a formula of ax squared plus bx plus cy squared plus dy plus e equal to 0.
The graph of the ellipse of the American football ball we worked as a team on. In here we can clearly see the domain and the range. The domain is from negative 18 to 25 and the range is from negative.
We chose ellipse-shaped sunglasses to explain and interpret the application of our figure in real life. As you can see, this is a horizontal ellipse, since the measurements of the horizontal side, major axis, are bigger than the vertical measures, minor axis. In addition to that, they are shaped like two parabolas facing each other.
This is what we chose for a real-life situation or object for an ellipse.
We learned as a team the difference between the ellipses, circles, and all the hyperbolas.
We worked really well as a team and we all put our efforts and hearts on it.
We also learned how to take real-life situations and convert them into math.
And how to solve them.
Okay, for this project, I learned a lot about ellipses. At the beginning, I thought we had the most difficult figure for the project, but then I realized that it was actually a pretty easy figure to do, and it helped me a lot to figure out about circles and parabolas. And my contribution for this project was the making of this video and the problems D and F, but still we all worked as teamwork, and we really put a lot of effort into this project.
During this project, we worked together to solve and to provide an explanation about ellipses and about the problem that we were given. I felt that this signature helped me get a deeper understanding about the topic we saw in class and how it could be applied in real life. I contributed by working alongside Maria to solve 5 of the sections of this project. In addition to that, I helped any teammate that needed my guiding or had any question about the issue.
We worked in solving and learning about ellipses. In this project, we learned how to work as a team because each of us solved a problem in the section of ellipses, and we also learned how to solve this problematic in real life with the soccer ball and with the balls that we measured in the ellipses, and we learned how to do all the measurements and the differences between ellipses, circles, and all the hyperbolas.
Overall, I believe this project was very helpful and interesting since it not only allowed us to deepen our knowledge, but also learn how to create ellipses with given measures and be able to transform them into standard and general equations. During this project, I worked with problems E and F, but I also helped my teammates with whatever they needed.